Uncertainty is not simply the absence of information. It is a specific psychological state, one that activates distinct patterns of thought and behavior. When humans encounter uncertainty, the brain does not remain passive. It searches for patterns, generates predictions, and sometimes manufactures certainty where none exists. Understanding how the brain responds to uncertainty helps explain why people react differently to the same ambiguous situation, why some forms of uncertainty feel tolerable while others feel unbearable, and why the need for resolution can sometimes override rational judgment. This video explores how humans process uncertainty, what the brain prioritizes when information is incomplete, and why uncertainty itself can be more distressing than negative certainty. The brain's predictive nature. The human brain is fundamentally a prediction machine. It constantly generates expectations about what will happen next, what a sound means, what a pattern indicates, and what an outcome will be. These predictions allow the brain to operate efficiently. Rather than processing every detail of the environment from scratch, the brain uses past experience to anticipate the present. This works well in stable, predictable environments. But when the environment becomes unpredictable, the brain's reliance on prediction creates tension. Uncertainty disrupts the predictive model. The brain is receiving signals that do not match its expectations, and it cannot generate a confident forecast about what comes next. This mismatch between expectation and reality is registered as a form of error, and the brain responds by increasing attention and arousal. Uncertainty is inherently alerting. The initial response to uncertainty, increased vigilance. When uncertainty is first detected, the brain shifts into a more vigilant state. Attention narrows, focus intensifies, and the mind becomes more sensitive to new information. This response is adaptive. In genuinely ambiguous situations, increased vigilance helps the brain gather the information needed to resolve uncertainty. A sound in the dark could be harmless, or it could be a threat. The brain does not yet know, so it heightens sensory awareness and prepares for multiple possibilities. However, this heightened state is metabolically expensive. The brain cannot sustain intense vigilance indefinitely. If uncertainty persists without resolution, the brain begins searching for ways to reduce the discomfort. This is where prediction, inference, and pattern seeking intensify. Pattern seeking under uncertainty. When information is incomplete, the brain often attempts to fill the gaps. It looks for patterns, even in random data. This tendency is not a flaw. It is an extension of the brain's predictive nature. By identifying patterns, the brain can generate expectations and reduce the sense of unpredictability. But this process has a side effect. The brain sometimes perceives patterns that do not exist. A person waiting for medical test results may interpret the timing of a phone call as significant. A gambler may believe they have identified a system in a game of chance. A student may read meaning into an instructor's tone of voice. These interpretations are not necessarily accurate, but they provide a temporary sense of structure. The brain prefers a coherent story, even a potentially incorrect one, over the discomfort of sustained ambiguity. This is why superstitions, rituals, and magical thinking often emerge in high uncertainty environments. They offer the illusion of control and predictability, tolerance for uncertainty, individual differences. Not all people respond to uncertainty in the same way. Some individuals can tolerate ambiguity with relative ease, while others find it deeply uncomfortable. This difference is often described as intolerance of uncertainty. People with high intolerance of uncertainty tend to experience ambiguous situations as more threatening. They seek resolution more urgently, and they are more likely to engage in behaviors designed to reduce uncertainty, even when those behaviors are not helpful. For example, they may repeatedly check for updates, ask for reassurance, or make premature decisions simply to escape the discomfort of not knowing. This is not a character flaw. It reflects individual variation in how the brain weighs the cost of uncertainty against the cost of action. For some, the distress of waiting is greater than the risk of making a suboptimal choice. For others, the distress of premature commitment outweighs the discomfort of remaining in limbo. Neither approach is inherently better. They are simply different strategies for managing the same cognitive tension. Uncertainty. Aversion, why not knowing feels worse than bad news. One of the most counterintuitive findings in uncertainty research is that people often prefer bad news to no news. When given a choice between learning a negative outcome immediately or waiting to learn an uncertain outcome later, many people choose the immediate negative outcome. This phenomenon is called uncertainty aversion. The brain finds prolonged uncertainty more aversive than predictable negativity. A person waiting for a job interview result may feel more distressed during the waiting period than they would feel upon receiving a rejection. The rejection is unpleasant, but it is conclusive. Uncertainty, by contrast, keeps the brain in a heightened state of alertness, unable to plan, unable to adapt, and unable to close the mental loop. This is why people sometimes seek closure even when closure will bring disappointing information. Resolution, even negative resolution, allows the brain to stop monitoring and start adjusting. The role of control in managing uncertainty. One of the most effective ways the brain reduces the discomfort of uncertainty is through perceived control. When people believe they can influence an uncertain outcome, their distress decreases, even if their actual ability to influence the outcome is minimal. This is why rituals, routines, and preparatory behaviors feel psychologically comforting in uncertain situations. A student reviewing notes before an exam may not significantly improve their performance, but the act of reviewing creates a sense of agency. The brain interprets the behavior as exerting control, and this reduces the intensity of uncertainty-related distress. However, this same mechanism can become problematic. When people overestimate their control over inherently uncertain outcomes, they may invest excessive effort into futile strategies or experience disproportionate guilt when outcomes are unfavorable. The brain's need for control can distort its assessment of what is actually controllable. Uncertainty and decision-making. Uncertainty fundamentally alters how people make decisions. In the presence of uncertainty, people tend to delay decisions longer than they would under certainty, seek additional information even when it is unlikely to be useful, rely more heavily on heuristics and shortcuts, experience decision fatigue more quickly. These changes occur because uncertainty increases the cognitive load of decision-making. When the outcomes of choices are unclear, the brain must simulate multiple scenarios, weigh probabilities, and tolerate the discomfort of not knowing which choice is optimal. This process is mentally taxing. As uncertainty increases, people often shift from analytical decision-making to intuitive decision-making, relying on gut feelings, past experiences, or social cues rather than systematic evaluation. This is not necessarily irrational. In highly uncertain environments, intuitive strategies can be as effective as analytical ones, because the available information is insufficient for precise calculation anyway. The brain adapts by using the tools that require less effort and produce acceptable outcomes. Chronic uncertainty and mental strain. While brief periods of uncertainty can be manageable, chronic uncertainty creates sustained psychological strain. When uncertainty persists over weeks or months, the brain cannot fully relax its vigilance. It remains in a state of prolonged alertness, scanning for resolution, and consuming cognitive resources that would otherwise be allocated to other tasks. This is why periods of prolonged uncertainty, such as waiting for a medical diagnosis, navigating job insecurity, or living through social upheaval, are so mentally exhausting. The brain is not experiencing discrete moments of stress. It is operating in a continuous state of unresolved tension. Over time, this can deplete mental resources, reduce capacity for focus and planning, and increase vulnerability to anxiety and rumination. The brain is designed to handle acute uncertainty, but it struggles with chronic ambiguity that offers no clear path to resolution. How humans seek closure. When faced with uncertainty, the brain often prioritizes closure over accuracy. Closure refers to the psychological sense that a question has been answered or a situation has been resolved. The brain values closure because it allows cognitive resources to be reallocated. An open question demands ongoing attention. A closed question does not. This is why people sometimes accept incomplete or oversimplified explanations. A partial answer that provides closure may feel more satisfying than a nuanced explanation that preserves ambiguity. This tendency can be problematic in complex situations where premature closure leads to misunderstanding, but it is also adaptive. In many everyday contexts, rough closure is sufficient, and insisting on perfect certainty would paralyze action. The brain is balancing the need for accuracy against the need for efficiency. Implications for daily life. Understanding how the brain processes uncertainty helps explain common reactions. Why waiting for results feels worse than receiving bad results. Why people develop rituals in high-stakes situations. Why ambiguity triggers more anxiety than clear risk. And why the need for answers sometimes overrides the need for correct answers. Recognizing these patterns does not eliminate the discomfort of uncertainty, but it reframes it. The distress is not a personal failing. It is the brain attempting to resolve a state that evolution did not optimize for prolonged endurance. Strategies that reduce perceived uncertainty, even without changing actual uncertainty, can be effective, not because they are delusional, but because they address the brain's need for structure and predictability. Closing reflection. Uncertainty is not simply the absence of knowledge, it is an active cognitive state, one that demands attention, energy, and resolution. The brain does not wait passively for information to arrive. It searches, predicts, and sometimes constructs certainty where none objectively exists. This response is not irrational. It is the brain managing a fundamentally uncomfortable situation with the tools it has available. Understanding this does not make uncertainty easier to tolerate, but it makes the reaction to it more intelligible. Uncertainty is not a gap to be filled immediately. It is a state to be navigated, with the awareness that the brain's urgency for resolution is not always aligned with the timeline of reality. And once that is understood, the pressure to resolve uncertainty prematurely begins to ease, replaced by a more sustainable relationship with not knowing.